In this video, I want to go ahead and talk about one-step equations. We're going to do some background information before we get into lesson 6.2. It's very important. There's a lot of steps here. I kind of got to have some things for you to go through. The first thing is to evaluate the expression, okay? Look at what you're given and see what's in there and ask yourself, what do I got to do with this? What math operations are there? Addition, subtraction, multiplication, division. You got squares and that kind of stuff. The goal then is to isolate the variable. And I'm going to show you on the next screen, point out some pieces to you, but we got to get the variable by itself on one side of the equation. What we have to do is we have to remove the constants first. I'm going to show you how we're going to do that. The second thing is we have to remove the coefficients if they're around the variables. And then the last thing we need to do is we need to check or prove your answer by putting what you got back into the original equation and then using the original equation to see if you get the answer. So for some background information, I've shown up two simple equations here that we can go ahead and use. First one is 5 plus z equals 8. Certainly you guys could just know that 5 plus what number would equal 8, and that would be 3. But what I want to point out here is that the 5 and 8 are considered the constants, but it's this constant here that we're going to work on to try to remove, because we have to figure out what z is going to be so that we can get 8. And I'm going to show you how to do that in the next slide. Here I had mentioned we have to get rid of the coefficients. Well, coefficient is what multiplies the variable. So it's right up here in front. That's the coefficient. So we're going to have to find ways to be able to get rid of that. Of course, you would get rid of the constant first, and then you would get rid of the coefficient, and we're going to show you what we have to do there. So here I have 5 plus z equals 8, and what we have to do is we have to remain in balance whenever we do something. When you're trying to get rid of the coefficients and the constants, what I mean by get rid of is you're always trying to get these to make them 0. And in math, what we do on one side of the equal sign, we can do on the other side, and that keeps our balance. So this is a positive 5, so if I want to make this 0, I have to subtract 5 here, and I also subtract 5 on this side. A technique that I find is to draw a line. That's still my equal sign, okay? So 5 minus 5 is 0. I bring down my z, okay, because I haven't done anything to it. So that's going to be plus z. And then 8 minus 5 is going to be 3. Well, 0 plus z is z, because 0 plus anything will always give you that anything. And then, of course, I'm not doing anything further with the 3, so z equals 3. Now, certainly you knew 5 plus 3 equals 8, and you can figure that out. So in this example, though, I've switched it up. I have now negative 5 plus z equals 8. So this is where our integer rules come into play. But let's take a look here. Remember, we have to keep things in balance, okay? So I'm just going to create my line down here. I'm at a negative 5, so how do I take negative 5 to 0? Well, I'm going to add 5, okay? Because this is the opposite condition. Remember, we learned about opposites in the number sense unit. So negative 5 plus 5 is 0. What I do here, I have to do over here. So I'm going to add 5 to 8. I'm going to bring down my z again. 8 plus 5 equals 13. So z equals 13. I also asked you to go ahead and do a check. So if I do negative 5 plus 13, I'm going to substitute the 13 in place of z. So I'm going to substitute it, put it in there. Okay. So now I have negative 5 plus 13 equals 8. You can use a number line to check that out. You can go through your integer rules to verify that also. So let's look at negative 4d equals 16. Remember, we're still doing one-step equations, so it's just one step. So this is a coefficient. Now, if you remember, this is really negative 4 times d. So what's the opposite of multiplication. That's right, it's division. So I have to divide negative 4 by negative 4. What I do on one side of the equation, I'm going to do on the other. So negative 4 divided by 4 is really 1, right? And a negative divided by a negative is a positive, so I'm going to have 1d. And that's going to equal 16 divided by negative 4. Well, a positive divided by a negative is a negative, and of course 16 divided by 4 is 4. So I have 1d here, but we don't usually write it that way. This is, of course, 1 times d. So 1 times anything gives us whatever that anything is. So we just write it as d equals negative 4. So in this example, what if I have negative 1/4 d equals 16? So I still go through my same procedures. This means to multiply, so I'm got to get rid of my coefficient. So negative 1/4 times d. So the opposite of multiplication is division. So I'm going to use exactly what this gives me right here. So I'm going to take negative 1/4 divided by negative 1/4, because anything divided by itself is always going to give me 1, right? But I also have to do the same thing over here. So draw my line to separate. So 16 divided by negative 1/4. So if you go through your fractions, okay, I'm going to write 16 over 1, and I want to remember this is a complex fraction, so I'm going to divide that. I'm going to write this in a format that I understand better. Negative 1/4. Okay, so we do our KFC. So I have 16 over 1 times 4 over negative. So if I go 16 times 4, it's going to equal 64 over, and then 1 times the negative 1 is going to be negative 1. So then I have a 64 over negative 1, that's going to equal negative 64. So if I put it back into the equation, remember I'm going to substitute this in place of d. I'm going to redo the equation over here. Negative 1/4 times 64 equals 16. So if I take negative 1/4 times 64 over 1, okay, that's 64 over 4, negative 4, okay, because I'm going to keep my negative. 4 goes into 16, so if I do the long division way, which you have to know how to do, so 4 over into 64. 4 goes into 16 once, that's 4. Bring down 2. Bring my 4 down. 4 goes into 24 6 times. So that equals 16. And then I have a positive divided by a negative, so negative 16. So I've proven out, so I've gone ahead and done some of the work. And here I have the negative 1/4 times the negative 64 equals 16, because a negative times a negative is positive. So going through the actual steps, negative 1/4 times negative 64 over 1 is going to equal negative 64 over negative 4, because remember you just simply multiply straight across. Okay, and then you go ahead and do the division, and I showed that longhand over here. So 4 goes into 6 one time, so 6 minus 4 is 2. Bring down the 4. 4 goes into 24 16 times. I'm sorry, 6 times. So that gives me 16. And again, a negative divided by a negative gives me a positive. Okay, so one last example here to show you one step and still continue on using fractions. So I have negative 2/5 times c, because remember that means to multiply, equals 1/3. So I have to get rid of my coefficient over here. So to the opposite of a multiplication is division. So I'm going to divide by negative 2/5, because anything divided by itself is always equal to 1. I'm going to bring my c down. But what I do on one side of the equation, I have to do on the other side. So I'm going to take my 1/3, I'm going to divide that by negative 2/5. I'm going to rewrite this in the format that I better understand a complex fraction. That's one of the things you have to recognize. So 1/3 KFC, keep, flip, change. First term, 1/3, going to multiply by 5 over -2. So if I multiply straight across, it's going to give me 5 over -6. So that's what C is going to equal. Okay, so C is going to equal, so if I rewrite my equation, -2/5 times 5 over -6, does that equal 1/3? Well, I have to do this work here, okay? So if I take these two, multiply, so that's going to equal 10, and I take 5 times 6, that equals 30. I have a negative times a negative, that's a positive. And if I reduce 10 over 30, that's going to equal 1/3. So actually, that's a proportional relationship there, okay, if you take a look at that. So those are some of the things for one-step equations. I hope they help you out as we move into 6.2.